This is our Algebra 2, Unit 2, Rational Expressions and Equations review. This is for our quiz to cover 2.1 and 2.2. So as you can see, it's a little long, but remember, we always practice harder than we actually quiz. So our quiz is not near this long, but you do need to know how to do all these skills. And the best way to get good at it is by doing lots of practice. So factor each polynomial completely. So this entire page right here is just factoring. So first of all, we should always look for a GCF. Try to do a little simplified factoring chart here, a factoring flow chart. So we should always check for a GCF, and if we have one, we should take it out. And then remember, we've got two options basically. We've got do we have a binomial or do we have a trinomial? And if it's a binomial, it's a difference of two squares or a difference of two cubes or a sum or difference of two cubes. And if it's a trinomial, we look at is a equal to 1? And if so, we can play the magic numbers game. We can find the factors. Or if it's not equal to 1, we'll do slide and divide to figure out, or the AC method, but I do slide and divide to figure out the factors. So let's look at number 1. First of all, is there a GCF? No. So I have a binomial, and I notice that it is a difference of two squares because 4 is a square number, 121 is a square number. It's a difference. X squared is a square number. So really, we just have to do 4x plus 11 times 4x minus 11. Okay? All right, next one. Do we have a GCF? Well, I notice, first of all, they have an X in common, but they also have a 5. Let me make sure that 5 is the biggest one. Yes, so I'm going to take out 5x. So if I take out 5x from 35x squared, I have 7x, and you can double check that. 5x times 7x is 35x squared, minus 15x, take out 5x or divide by 5x would give me 3. And then you ask yourself, can I reduce that anymore or factor it anymore? And the answer is no. So that one is factored completely. All right, number 3. Do I have a GCF? No, but I have a trinomial and my a is equal to 1, so I know that I'm going to play the magic numbers game. So what factors of 32 are going to add to give me negative 12? Well, let's start. I've got 1 and 32. I've got 2 and 16. I've got 3. I've got 4 and 8. 5, 6, that's it. Okay, so you can see that 4 and 8 are the combination that's going to give me 12 when I add, but let's play with the signs. What's going to give me positive that would add to give me negative? And of course, those would have to both be negative because negative 4 times negative 8 is positive 32, and negative 4 plus negative 8 would be negative 12. So x minus 4, x minus 8. There you go. All right, let's keep on going. All right, first question you should always ask yourself when factoring is there a GCF? And when I look at this, I do not see one. So let's go ahead. That means we've got a trinomial, and we are going to have to factor it using the slide and divide method or the AC method, but we use slide and divide in my class. So hold on just a moment, and we'll get that factored. All right, so what I do is slide and divide is we take our A value and slide it over to our C value. And so this makes, and we multiply those. This makes our X squared now have an coefficient of 1. So our A value is now 1 and minus 23x. And we're going to do 6 times 20, which is going to be plus 120. So remember, this is not our final answer. This is like our slide part where we slide and multiply. And then remember, we still have to divide once we've got this factored. So now we can play the magic numbers game and we can try to factor this. So what factors of 120 are going to add to give me negative 23? Now, these numbers are kind of big, but don't be intimidated. You have a calculator. You can go through them if your multiplication skills aren't super great. Start with what you know. I know 1 and 120. I know 2 and 60. I know 3 and 40. I know 4 and 30. 120 divided by 5 is 24. So I know 24 or 5 and 24. Um, let's see. I know we've got 120 divided by 6. So I'm going to have to do a second column here. I've got 6 and 20. 7 won't. 8 and 15. And I'm always looking, especially on these super long factors, I'm always looking for what's going to work. And it's okay to write down all the factors and keep trying to figure out. Don't freak out when the numbers get big. You just keep doing the process that you know works. And so I can see right here that 8 and 15 are going to be my factors. Now, there are more factors, and if you didn't catch that at first, you could just keep listing those. But I can see that 8 and 15 are going to be my things that give me 120 and will add to give me 23. So let's figure out the signs. So they're going to give a positive 120 and an add to get negative 23. So these will both be negative. So I'm going to say x minus 8 times x minus 15. Now remember, that's not our final answer. That's our helper trinomial. That's the one we did with slide, right? Remember, slide and divide. So we're going to divide by 6 because that's what we multiplied by. That's our kind of our final step. So we did the multiply to help us out so we could factor, and now we're dividing. Okay, so let's reduce this if we can. 8 divided by 6 reduces by 2, and that would be 4 over 3. Okay, but remember, we do not like to have fractions in our factoring like that, so we bring the 3 out to the front, and so we're going to say this is 3x minus 4. And then 15 divided by 6, we could reduce that by 3. That's going to be 5 over 2. And so again, we don't like to have fractions like that in our factors. So we bring the 2 out front, and we're going to say 2x minus 5. That was kind of a big one, but the process works. Okay? All right, let's look at number 5. I already ran into their workspace. All right, so what do we notice first? Well, first I noticed that there are 4 terms. And up here, I forgot to mention that the first thing we should always look for or try is if we have 4 or more terms, we should try grouping. Okay, or not should try, we do try grouping it. And then we look at our GCF and then we can go from there, okay? So when I see that I have these 4 terms, I group them because that's going to help me. And then I go and look for a GCF. So in my groups. So in this group, I can see that they have an x squared. They both have at least an x squared, and that's it. So I'm going to pull out x squared, and that leaves me with x plus 3. And anytime we've got like a leading negative there, I'm always going to pull out the negative with it. And here it looks like they have a -4 in common, right? Because 4 will go into 12. So I'm going to pull out a -4, and that's going to leave me x. And if I pull out a -4 from a -12, that's going to give me positive 3. And this is what we want to happen when we group. Okay, we want to see that we ended up with similar, or not similar, but identical factors. And so we're like, okay, so x plus 3 is in common. And then we write what's left, x squared minus 4. Now remember, what you always have to ask yourself is, am I done factoring? So look at what's left and see if you can take it further. Always be checking to see if you can take it further. And should have noticed that this right here is a difference of squares. And so we can say x plus 3 times x plus 2 times x minus 2. And there you go. All right, the last one to factor, but don't worry, we're getting lots of practice down here too. So it says, let's factor 18x squared minus 8. Well, first thing we should always check for, we don't have 4 terms. but we can check for a GCF. And you do notice or should notice that these both have at least a 2 in common, and I think that's all they have. So if we pull out that 2, that's going to give us 9x squared minus 4. Okay, so let's keep looking though. Can I take this further? What's left? Can I factor that even more? Well, if you look at this, we're left with a binomial, so your brain needs to go to like, is it a difference of cubes or is it a difference of squares or some are difference of cubes, sorry. Um, and I look at this and I'm like, okay, 9 is a square number, x squared is a square number, 4 is a squared number. So yeah, this is a difference of squares. So I can go ahead and factor this some more. So this would be 3x plus 2 times 3x minus 2. And don't forget the 2 that you already factored out. There you go. That's our thoughts on factoring. All right, number 7, true or false. When simplifying a rational expression, you need to find a least common denominator before multiplying and dividing. Guys, don't overthink this. When you multiply and divide expressions, think about what you do with actual just regular old fractions that we worked on, since like 5th, 6th grade. Do we need a common denominator when we are multiplying or dividing? No, we do not need a common denominator. So this one would be false. We need a least common denominator when we add or subtract, not when we multiply or divide. Okay, so number 8, it says simplify each rational and state any restrictions. Okay, remember the restrictions are where x cannot equal 0. Okay, so, and that's where our denominator. Okay, so keep that in mind. And we'll go through it. Okay, so number 8, it says, let's factor this, or not factor it, but let's add these two together. Well, when we add fractions, just think of them as fractions. When we add these together, we need a least common multiple, which is the same thing as our least common denominator, okay? Least common multiple is just what you would have if you didn't have it in fraction form and you were just trying to find out what they would all have in common or what they all need. But this one is, a denominator. So let's factor these and see what they actually factor down into. Remember, guys, we're always trying to factor. We're always looking at them in their factored forms. So I can see that this 6x plus 3 has a 3 in common. And actually, I'm just going to write this whole thing over. Okay, has a 3 in common. So that would be 2x plus 1 plus, and this one just has 2x plus 1. Okay, so let's look at what they would both have to have. They both have to have every factor in them, every factor that shows up. And so if you look at this one has a 3, but this one doesn't, but they do have to have a 3. And this one has a 2x plus 1. And this is just a 2x plus 1. So 3 times 2x plus 1 is going to be the least common denominator. Okay, and I'm going to write that out. Okay, now look at your original fraction, your original rational expression, and see what we are missing, and we have to multiply the numerator by that. Am I missing anything to go from here to here? No, I'm not missing anything, so I'm not multiplying by anything extra. Now remember, don't get confused. These are not separate factors. Since they are being added, they're actually one factor together. So you might want to put parentheses around those to make sure you don't accidentally cancel things in a minute. All right, 2x plus 1, it's missing a 3 to go from here to here. We put an additional 3 in there. So that means we need to multiply by 3. And so that's going to become 3. Okay, so we have x plus 4 plus 3 over 3 times 2x plus 1. And we can simplify this a little bit. We can put our like terms together. 4 plus 3 is 7. So I have x plus 7 over 3 times 2x plus 1. And that's our final answer. We do need to go in and state when the restrictions are. So let's look at our answer here. And we are trying to figure out when x, we're trying to always look at, we know that in our denominator, x cannot be 0. And we always look before, like right before we kind of simplify, what really these are kind of the same, but if we're multiplying and kind of canceling some stuff out, we would look at the before we canceled. But if we look at this, we would say that 3 cannot equal 0, and that's like a moot point, right? Like we know 3 does not equal 0, but we do know that 2x plus 1 should not equal 0. Well, solve this. I'm kind of running out of room here, so I'm sorry, I'm kind of scrunching it together. And we just have this little bitty baby equation. So we see that 2x cannot equal -1, divide both sides by 2, and I get that x cannot equal -1/2. Because if it does equal -1/2, that would make the denominator 0, and that would make it like an impossibility. We cannot divide by 0. So this is the final answer. This is our restriction. X cannot equal -1/2. All right. These kind of take up some room, don't they? All right, so we are multiplying. Oh gosh, I like to see multiplication because we don't have to have a least common denominator. Woohoo! But we do need to factor the heck out of this, okay? So let's look at the numerator. We've got x squared plus x minus 12. We're going to have to factor each piece of these expressions, and I just always start and kind of work my way through. Okay, so let's look at this. This is a trinomial, and its a value is 1, so we can factor this. What with the magic numbers game? So what's going to give me -12 that would add to give me +1? Well, I can think through this. If you can't think through it, make a list of all your factors, but I can see that this would be x plus 4 times x minus 3. Okay, those would multiply to give me -12, add to give me +1. Okay. Um, Looking at the denominator, x squared minus x minus 6, so we have a trinomial, there is no GCF. A is equal to 1, so I can factor this with the magic numbers game. So what would give me -6 that would add to give me -1? Well, you can go through and list all the factors if you like, but I know, let's see, there's 1 and 6, and there's 2 and 3. So we know it's 2 and 3, and since we're adding, and that means the bigger number is positive or negative because we got a negative there, that means it's going to be x minus 3 times x plus 2. All right, so now we're multiplying, and 3x minus 6 in this numerator. So that's got a common factor of 3, so let's do x minus 2. And then here we can take out a common factor of x, so we get x plus 4. All right, I have factored everything. And what's nice about multiplication is now that you've done this, you can just jump in and start canceling factors in the numerator that exist in the denominator. Now remember, I just work through from left to right methodically to cancel stuff. And once I get to the other side, everything that's left over, I just rewrite. So x plus 4 can cancel. I have an x minus 3. I don't have anything that'll cancel with the whole number 3 down here, so that's going to stay. And I have an x minus 2, and I only have an x plus 2 here. So that's okay. I've made it through, and I'm going to write what's left over. So 3 times x minus 2 over x times x plus 2. All right, guys, I apologize. This video I cut through, I forgot to hit record again. I paused the video really quick for something. I forgot to hit record on this part of the video. So let me talk you through it. We factored it. We figured out what we didn't have, and so we made a big list of our common denominator. We figured out what we didn't have in each one. We multiplied by it, just like we did in number 8. And then we have to combine our like terms, being careful that this is subtraction. So we are subtracting the 3x and subtracting a -3, which would be adding 3. So let's continue. 2x minus 3x is -x plus the 3. And then we've got our denominator still. All right. Now, I tend to write things out a lot because I like you to see my thought process and I like to think it out with you. If I were solving these on a quiz, I would still probably do all the things. Now, once you get really good at it and you see what's happening, you could shorten this a little bit. You don't have to write everything out like I do, but it's also good just to see it step by step. Okay. Now, here is my final simplified answer, but I got to look at the restrictions. So remember, we're looking at our restrictions of what's in our denominator. We didn't cancel anything out in our denominator, so we can just look at this and say, okay, well, 2 can't be 0. That's fine. 2 is 2. Okay, so we have here that x plus 1 cannot be 0 and x minus 1 cannot be 0. And so that means that x cannot be, if you were to solve this, x cannot be -1 or +1. So you could write them out as two different answers here, or you might see it as x cannot equal plus or minus 1, because that's saying the +1 and the -1. So however you write it, it's fine. It's saying the same thing. Okay? All right. I write big and I'm running out of room. Okay, so let's keep on going. All right, so number 11, we are simplifying, and it looks terrifying, but it's a complex fraction. Okay, that's all it is. And it's a division and division, division. So it's actually not going to be one that's, too difficult. So the first thing I'm going to tell you guys to do is to rewrite it as an actual division problem. So we've got x squared plus 4x plus 3 over x squared minus 2x minus 15 divided by x squared minus 1 over x squared minus x minus 20. Okay, so that's your first step. I haven't done anything. I'm just trying to get it ready in my head so I don't make a mistake. Now, when I divide, I can never just divide the fraction. I have to multiply by the reciprocal. So I know this seems like a lot of extra writing, but the more you write down and the less you do just in your head, the less likely you are to make mistakes. Okay, so we multiplied by the reciprocal, which means we flip that last fraction. Okay, now we're ready. Now we can actually do what we've done before. It's a multiplication problem. We just have to factor and cancel out the factors. So I can see that this here is a trinomial. There's no GCF, and A is 1. So I'm going to play the magic numbers game. Now, if you need to go off to the side and do the magic numbers game, we've done it enough that you know how to write it and what to look for. So we're looking for factors of 3. What's going to multiply to give me 3 that would add to give me 4? So I can see here that it's x plus 1 times x plus 3. Okay, next one. What about x squared minus 2x minus 15? Well, again, it's a trinomial. There's no GCF. A is equal to 1. Magic numbers game. Okay, so what's going to multiply to give me -15, that's going to add to give me -2? Well, I know that 3 and 5 make 15. So let's do x minus 5 times x plus 3. And let's just make sure. -5 times 3 is -15. -5 plus 3 is -2. Yes, that works. Okay. All right, let's look at this one. X squared minus x minus 20. Again, no GCF. A is equal to 1. Magic numbers game. What's going to multiply to give me -20? That would add to give me -1. Well, again, you can write it off to the side if you want, but I know that that's going to be x minus 5 and x plus 4. And then you can always just check it. That makes -20, and that adds to make -1. So yes, we're good. All right. And then x squared minus 1, no GCF. It's a binomial, so it's either sum or difference of cubes or a difference of squares. And we can see this is squares, right? So we're going to have x plus 1 times x minus 1. All right, now with multiplication, it's really good because right now we just start going across and canceling stuff out. So x plus 1, do I have an x plus 1 in the bottom that I can cancel with? Yes. So I have 1 in the numerator, 1 in the denominator. X plus 3. Yep. X minus 5. Yep. X plus 4. Nope. And so once I make it through my numerator, I don't have to go back and check my denominator because I've been checking it at the same time, right? So I just write what's left over. So I have x plus 4 over x minus 1. Now, the restrictions have to come from what we had before we started canceling. So if I look at this, now I'm going to start doing some of this in my head just so I can write less. If you need to write it out every time, you can. So I know that x minus 5 cannot be 0, which means x cannot be positive 5, right? X cannot be positive 5. I know that x plus 3 cannot be 0, so I know then that x cannot be negative 3. I know that x plus 1 cannot be 0, so I know that x cannot be negative 1. And I know that x minus 1 cannot be 0, so I know that x cannot be positive 1. Okay? Now, they should be written in order from least to greatest, so if you need to take a second and kind of rewrite them, you can. So I know that x cannot be negative 3, negative 1, 1, or 5. Now, I'm not really sure what a big deal that is. I mean, they should be written in order from least to greatest. You should get in the habit of doing that. But that's what your restrictions are. Okay, now you may have chosen to write plus or minus 1 instead of writing it out as two separate numbers, and that's okay too. All right, let's look at number 12. We've got an addition problem, so I know that means I need a least common denominator. So first, before I can find that though, I need to factor these. So y squared minus 12y plus 27, there is no GCF. It's a trinomial, so I'm going to play the magic numbers game. What's going to multiply to give me 27 that would add to give me negative 12? Well, I know that that's going to be y minus 9 and y minus 3. And you can always check it. Does negative 9 times negative 3 give me positive 27? Yep. Does negative 9 plus negative 3 give me negative 12? Yes. And then, of course, we've just got the y minus 3. So if you look at this, we need all the factors that could show up in the denominator. So I have a y minus 9. I have a y minus 3. And I also have a y minus 3 here, so I don't need to write it twice, okay? So y minus 9 times y minus 3 is my denominator. All right, well, let's look at this. In my original, I had y minus 9 times y minus 3, so I didn't change anything. I didn't have to add anything in, and so that means my numerator is still just 2y minus 5. Now, I didn't mention it, but I did mentally factor that to see if it could factor, and it didn't, okay? Now look at this one, y minus 3. Okay, the only thing that I added to it was this y minus 9, so that means I need to multiply by y minus 9. So that's 8 times y minus 9. All right, so let's keep on going. So I have y minus 9 times y minus 3. I have 2y minus 5. Now, this is addition, so it's okay to the signs aren't going to be changing like we did when we were subtracting. So this is plus 8 times y is 8y, and 8 times negative 9 is negative 72. So we're adding negative 72, so just minus 72. All right, combine our like terms. 2y and 8y is 10y. Negative 5 minus 72 is negative 79, and we have y minus 9 over y minus 3. Sorry, guys, that's 72. All right, 77. Good grief. This is what I get for working on a Sunday morning. So 10y minus 77. Sorry. Now, if I could try to factor this, I would to see if anything else would additionally cancel out, and it doesn't. So my final answer is just 10y minus 77. over y minus 9 times y minus 3. All right, so then my restrictions are what can't be in the denominator. Well, of course, it can't be 0. So let's look, because we always need to look before we start canceling things in our denominator. And so like these, they're the same, so we can look at them. So I know that y minus 9 cannot be 0. So I know that y cannot be positive 9. And I know that y minus 3 cannot be 0, so I know that y cannot be 3. Now, if you're going to be picky, you can say y cannot be 3 or 9 because we're going to list them in order from least to greatest, but that's our restrictions. Okay? All right, let's keep on going. So we've got an addition one to do yet and a division one to do. And then we've got, some more on the back, of course. But let's keep going. So when I see an addition problem, I automatically think LCD. I need to find a common denominator. Now, this one has 3 terms that we're adding together, and it's absolutely fine. You treat it the same way. So let's go ahead and find the factors. We need to factor this. Now, these two are already broken down into their factors because they can't factor anymore, but this one can. Now, I have a trinomial and a is equal to 3, not 1, so I'm going to have to do slide and divide really quick, and I am going to go off to the side because I cannot do slide and divide in my head. So I have x squared plus 2x minus 3, because 3 times 1 is 3, and what is going to give me that? So what's going to give me negative 3 when I multiply that will add to give me positive 2? And so that would be x plus 3 times x minus 1. And you can check it. Plus 3 times negative 1 would be negative 3, and then add those together, that would give me positive 2. All right, so this is my slide and divide part, or slide part. Now I need to divide by what I multiplied by. So we're going to divide by 3. This, of course, becomes 1, so it's just x plus 1. And this will not simplify, but we're going to make it look like 3x minus 1. Okay, so I had to do a little off to the side work, and that's what is kind of a pain about all this stuff, is that there is a lot of work to do. Okay, so I'm going to factor this too while I'm at it. 6x minus 2 can factor, and so I'm going to take out a 2, and that's going to be 3x minus 1 over x plus 1 times 3x minus 1 plus, okay? So that's what I did first, okay? Now, what I want you to notice is sometimes when we do this, do you see that this fraction, if all we're looking at it, because if we can simplify fractions before we start doing stuff, it makes things a lot easier, right? Just kind of like with regular numerical fractions. And so do you see that 3x minus 1 are shared in this? So again, we're not looking at this as an addition problem right now. We're looking just at this fraction, this rational expression, and we could go ahead and simplify this. So I can say like, oh, hey, look, those cancel out. And now I can just think about this as an expression that's 2 over x plus 1. Okay, that'll make things a lot easier. So if you need to, just so you can see what's happening, we now have, and you can put those in parentheses if you want. We now have these 3 fractions to put together. Now again, I tend to write a lot of things out just so you can see all my thought process, but you can write a little less if you need to. You may not need to write this next step, but I just wanted to show you what was happening, okay? So let's look at this. What do they need to all have? Because they all need every factor. Well, it needs to have an x plus 1, that's an x plus 1 also, and it needs to have an x. So my final denominator is going to be x times x plus 1, or I should say my least common denominator. Okay, now let's look at this. This had an x plus 1, and now it also needs an x, so I'm going to multiply by x, so that's 2x. This had an x plus 1, but it also needs an x, so 7 times x would be 7x, and it's addition, right? This just had an x, it needs a 2x plus 1, or sorry, it needs an x plus 1, so that's going to be x plus 1. Now, I'm going to go ahead and do the math really quick. So 2 times x plus 1 would really be plus 2x plus 2. Okay, now the neat thing is, once we get really good at simplifying, you could have done this in many different ways and still came up with the right answer. So even if your work doesn't necessarily step by step match mine, you should still be able to come up with the right answer. Okay, so let's go ahead, simplify this a little bit more. We have some like terms, 2x, 7x, and 2x. So we have 11x plus 2. And there we go. There's our final answer. So it looks scary. It wasn't too bad, but we do need our restrictions. So we know that x cannot be, well, x cannot be 0, and x cannot be -1, right? Because x plus 1 equals 0. That'd be x equals -1. So I know that x cannot be -1 or 0. Those are the restrictions. All right. Okay. 14. Lots going on here. It's a division problem though, so the first thing I'm going to do is I'm going to write it exactly as it is, but I'm going to change it to multiply by the reciprocal, just so I don't forget that. Because you would hate to go through all that stuff and then realize you forgot to multiply by the reciprocal. So now it's a multiplication. Woohoo, we don't need LCD or anything, but we do need to factor a whole lot of this, okay? We have a trinomial, but the first thing we should check is, do we have a common factor? And if you see that, we do. I can take out a 3, and I have a squared plus 2a plus 1. And let's see if I can factor that anymore. It's a trinomial. A is 1. What are factors of 1 that would add to give me 2? Now, I'm getting kind of trying to be a little quicker, so the more, if you've noticed, the more we go through this, I'm starting to write it a little bit more shorthand, like I would actually solve it. But I know that this is going to be a plus 1 times a plus 1. So I'm going to cross this out, and I'm going to write it above it, a plus 1 times a plus 1. If you don't like the scribbly looking mess, then you can rewrite it nice and neat, okay? It all boils down to, what level of mess are you willing to look for, and can you still write it neatly enough that you can see the factors, okay? All right, now we've got this factored, the numerator as far as it'll go. Let's do this one. A is equal to 1. We can play the magic numbers game because it's a trinomial. So I know that this would be a, well, let's see. What would that be? Did I? Here's what caught me. I was like, what is not going to equal, like, it's not going to factor. But then I noticed I wrote it down wrong. I don't know why I put a 2 there when it's a 10. Okay. So what's going to give me a -10 that would add to give me -3? So I know that that's going to be 5 and 2. So a minus 5 times a plus 2, check it. That's going to give me -10, and it'll add to give me -3. Okay. A squared minus 4, that's the difference of two squares. A plus 2, A minus 2. And I can take out a 12, and I have A squared minus 1. Again, difference of two squares, keep going. So that would be A plus 1, A minus 1. Okay, so this is where I'm getting ready to cancel. Okay, so I do have, if you notice, I have a 3 that can share factors with 12. So 3 goes into 3 one time, and 3 goes into 12 4 times. I'm completely factored as low as I can go here. A plus 1. I do have an A plus 1 that I can cross out. A plus 1. Nope. A plus 2. I do have an A plus 2. A minus 2. Nope. So I'm done. I've canceled as far as I can go. So write what's left over. I have an A plus 1, and I have an A minus 2. I have an A minus 5. I have a 4. I usually like to write the actual numbers out in front. And then I have an A minus 1. Now, again, if you didn't simplify as far as you thought, you'll catch it right here because you'll be like, what? I can keep simplifying. And if that's the case, go for it and then continue and then rewrite your final answer. But this is our final answer here. All right, so here's my final simplified answer, and I went ahead and wrote out the restrictions. You have to base your restrictions off of what you had before you started canceling. So I knew that A could not equal 5. I knew that A could not equal -2. 4 can never equal 0 because 4 is 4. I know that A plus 1 cannot equal 0, so I know A can't be -1. And then I know A cannot be +1. So when I'm thinking it through, I write it down and then I always just rewrite it in order from least to greatest. Okay. All right, guys, that's our stuff. We've got, a few more to answer, but that's like the big idea of what we were doing in these first two sections of this unit. So number 15, it says identify the least common multiple. Now, we keep talking about least common denominator. Now, a least common denominator is a least common multiple. The difference is if we're actually solving a fraction problem, we would call this a least common denominator, just like number 13, right? We'd need to find a least common denominator. This is not this is not a fraction problem. It just gives you three terms, three factors and says, hey, find the least common multiple of this. Okay, so it's the same exact process. It's just that's the difference. A least common multiple is just a multiple of things. A least common denominator is a denominator, but it's the same process. So just like we would have done, we're going to factor each of these and see and make sure that everything has the same, every factor shows up. 2x cannot be factored, x plus 5 cannot be factored. This can though. So the first thing you're going to look for is a GCF, and I have that. So it's x squared plus 2x minus 15. I'm left with a trinomial, so I'm going to try to play the magic numbers game since a is equal to 1. And so I've got, let's see, what's going to give me -15? So that's 5 and 3. And I need my 5 to be positive. So x plus 5 times x minus 3. Now, if you start to try to do it in your head like I do, always double check your math. 5 times -3 is -15. 5 plus -3 is 2. Always double check just to make sure, because then if you end up factoring wrong, then nothing's going to work out correctly for you. Okay, so let's find our least common multiple. I need a 2x. Okay, so I need a 2x. I need an x plus 5. I need a 2. I need an x plus 5, and I've already got it written down, and I need an x minus 3. And that is my LCD, or my LCM, which is just like my LCD, only I don't have a fraction problem. So it can't be called a denominator because it's not a denominator. All right, almost done. Okay, so 16, it says find the width of the rectangle given that the length is this and the area is this. Now, think what the area formula is. Area is length times width, okay? In order to find the width, I always think first, how would I manipulate this equation to help me find the width? Well, I'm going to divide both sides by L, and so I know that area divided by length is what would give me my width. Okay, so I'm trying to find the width. This is going to be a division problem. So my area is c minus 9 over c squared minus 2c minus 63 over my length, which is 4c over c minus 2. So it looks like it's a complex fraction, and it is, but we can set this up as a division really quick. I probably should have written more over here because I write so big. So we've got c minus 9 over, I'm going to start factoring at the same time. Actually, no. Yeah, I will. So c squared, so what's going to give me -63 that would add to give me -2? Well, I know 9 and 7 make 63, so that would be c minus 9 times c plus 7. Double check it, c minus 9, so -9 times 7 is -63, add -2. Okay, and then I know that it is division of 4c over c minus 2. All right, we cannot treat this like a division. We have to change it to multiply by the reciprocal. Okay, remember these are factors. You can't separate them separate, or you can't cancel them separately. So let's go through. Now it's just multiplication. All right, so I have a c minus 9. I can cancel that. I have a c minus 2. Nope. I have a c, and that's really it. Okay, so since I looked through the numerator and whatever's left over is what's the answer is. So we've got c minus 2 over 4c times c plus 7. And that is your answer. All right, so this is your width. Okay, it says find the width, so that's what we did. All right, let's look at this one. So 17 and 18 are related. It says a student's work is shown below. Identify the error, if any, is made by the student, and if the work is correct, circle no error was made. So our options are where did they make the mistake? Okay, so let's look. This was the original problem. It's a subtraction, so we know we're going to need a least common denominator and all the good things, right? So here is I will tell you that it is hard, even as a teacher, sometimes to look at work and find the mistake. So, what I would suggest doing is do the work and check it with their work, and then we can easily find the error. Okay. Now, some of you might be able to look through that and read through it and go, oh, here's exactly where the error is. But a lot of you will struggle looking because you have to think through the problem in your head. And sometimes thinking through in your head is difficult. So let's just do the math over here and compare it. Okay, so if I've got this problem, I'm going to go ahead and start by factoring. And so I can take out an x, and that's going to give me x minus 5. All right, so it looks like that's what they did first. Okay, so no error in number 1. It looks exactly like what I would have done. Well, the next thing that I would do is I would find my common denominator, right? So I need a 9, I need an x, I need another, or I need an x over here, but I already have one, and an x minus 5. So this, I wrote that a little close, is my denominator. Okay, so let's go through. I had this, and now I need all of this, so the only thing I don't have is the x minus 5. So that means I'm going to have 2 times x minus 5. This I have, I just don't have a 9, so I'm going to multiply by 9, so that would be 9 times x plus 2. Okay, let's check it with the last step, or the next step. 2 times x minus 5 minus 9 times x plus 2. Now they wrote it all over 1, and you can do that, but these are the same thing. So there is no error in step 2. Okay, let's keep going. So we would distribute this, so that would be 2x minus 10, and remember we are subtracting, so that's minus 9x minus 18 over 9x times x plus 5. Okay, because you're subtracting this. So this is 9x plus 18. So you would be subtracting 9x and subtracting the 18. That's a lot of times where people make mistakes. So let's look at the work. 2x minus 10 minus 9x. Oh, look, that's where they made their mistake. Okay, so it was made in step 3. So once we found that, we don't even need to keep going because I know that's where the error was. Now, it does say simplify the rational expression in number 17 correctly. Well, here's the nice thing. We've already done most of it, so I'm going to come down here and I'm just going to finish it out. So 2x minus 10 minus 9x minus 18 over 9x times x plus 5. Okay, well, let's combine like terms because we know that's where their mistake was. is that it should have been a negative, not a plus. So 2x minus 9x is negative 7x, and negative 10 minus 18 is negative 28. And we are left with 9x times x plus 5. And this is our final answer. Okay? All right, guys, it seems like a lot, and it can be, but it really boils down to factoring and how do you add, subtract, multiply, and divide. Okay, and so just think about how we normally do things with just regular numbers in like fifth grade, and we treat it and do it the same way. Okay, let me know if you have questions.